Your Next.js API routes are not secure, and it's kinda a miracle that nothing has happened yet. Or maybe something has already happened, and you don't know it yet. A lot of developers assume that their Next.js API routes are secure, but there are so many things you have to look at. Server-side validation, rate limits, authorization, not leaking sensitive data, proper error handling, and much more. But don't worry, in this free video I will show you how to build a super secure API route step by step. So now, without any further ado, I think it's time to roll the video. Let's go! So right here I have created a little example which will teach us everything about security and route handlers in Next.js. So inside of here a user can create a new blog article, and for this we have a form. We have an input for the title, author name and content. I can fill it out. For the title some gibberish, for the author name some gibberish, and if I now click on submit we get an error. That's because I have implemented client-side validation and it says content must be at least 10 characters long. So let me now add 10 characters, and if I click on submit you'll see a little delay, and then on the bottom right corner we see a toast which says article created successfully. Nice. Let's look at the code behind this magic. So if I open VS Code you'll see inside of here I have first of all implemented client-side validation as mentioned, and I've also created a video on client-side validation if you want to check it out. I will now create a little pop-up on the top corner somewhere, but yeah, we have client-side validation as mentioned, and then we have our return statement. In the return statement I return my card with all of my inputs, and for the form I have an onSubmit. Then this onSubmit calls my onSubmit function, and inside of here I do a fetch call, meaning at the end of the day I call my API route, the method is post, and as the body I pass all of my values, meaning again the title, author name and content. Then we of course also await our response and we do an if check. If the response was successful, if it was okay, we return a success toast. If we have an error, then we return a toast which says hey, something went wrong. And since we now know that, let's also open our route handler. So if you open the Explorer you will see the app folder. In the app folder I have an API folder, and the API folder has a child folder which is submission. Inside of there we have a route.ts, and this is our API route. Also quickly, if you didn't know, a route handler is an API route. This route handler term was created by the Next.js team to market it better, but at the end of the day, remember it like that, route handler equals to API route. Okay, now let's look at the route handler. Inside of here, we do an export async function post. We only accept a post request. If someone tries to do a get request, we will throw an error. Then inside of our function, we get our body, and then we do our mutation with Prisma. We create a new article and we pass the title, author and content for our data. At the end, I return a successful message with the message itself and a status of 200. And now if you look at the code, do you see any major problems, any major errors? I mean, there are major problems, but maybe you currently don't see them. So let me show you one major problem. As mentioned, we have client-side validation, as you all know, right? This means if I click on submit, we instantly throw errors. So this means that nobody should be able to submit the form without filling out every field, right? Well, let me show you something. So this is my terminal, and let me zoom in a bit, and with this terminal I will now submit my form. So I will do a curl request, this is a post request, and I will call my route. We have a content type of application JSON, and then I pass in title, author and content. Let me now click on enter, let's see, and we got a message, article created successfully. Let's open Prisma Studio. What do we have inside of here? And as you see, my first article, author Jan, content, this is the content blah blah blah. So as you now see, I submitted my form successfully. But okay, in this example, all the fields have been filled out correctly. Let's do another mutation, but for the content, I will only say yo. And if you can remember, for our content, we have to pass at least 10 characters. And now I only pass 4 characters. If I now click on enter, you'll see that everything was successful. Article created successfully. If you open Prisma Studio and do a hard refresh, you will again see my article. As you see, yo, but these are not 10 characters. These are only 4 characters. At the end of the day, I now submitted my form without doing any validation. And that's not what you want. And this is security issue number 1. So how do we fix this? Well, we fix it by doing server-side validation. So let's first of all again look at client-side validation. How did I create client-side validation? Well, I used a sort schema. So in my sort schemas file, I have created a sort schema. This is my block schema. This is equal to z.object, and then I create my title, author, and content. Now, if you have never heard about sort is in TypeScript first schema validation library. So the website is sort.dev, and as you see, TypeScript first schema validation library. And at the end of the day, what you do is you create a z object, and then you pass all of your fields, like for example the title, description, whatever, and then you add all of your further validation, as I did right here. For the title, I expect a string with a minimum of 1 character, and for the content, this is also string, but a minimum of 10 characters. So now I have my sort schema, and I can use the sort schema on the server side. So let's open our route handler, and inside of here, let's validate our request body. This means I can go underneath my constant body and we can do a constant validate data, and this will be equal to my block schema. Let's import that from our utils or from my sort schemas file, and we don't want to call the pass method but the save pass method. And as an argument, we want to provide our body. Now here's the thing, validate data could either be successful or not successful. So let's do an if statement and let's say, hey, if validate data is not equal to successful, then let's return an error message. So let's do next response.json, let's return a message and a status of 400. So in this if statement, we now check if our data is successful. If not, we return our error message. If it is successful, we can now at the end of the day update our mutation. So instead of providing our body.title, we can now provide our validate data.data.title. And let's do the same for the author and content, meaning validate data.data.author and .content. So now we have server-side validation. This means if I now again copy this curl command and paste it inside of here and click on enter, we get an error, invalid data. Nice. But now we actually have another error because we now check that our form data is actually valid, meaning that all of the inputs are filled out correctly, but we don't check what or who the user is. We don't check if the user is authenticated, if the user is an admin, if the user is even allowed to create a mutation. Because here's the thing. Insecure API is an internal block application system of a company, and only authenticated users which actually have the role of admin should be able to create a block article. This means we want to now implement authentication, check if the user is authenticated, and then we want to check if the user has the correct role and permission. So let's implement authentication. For that, we will use Kind, the sponsor of this video and my favorite auth solution. I have been using Kind for already I think almost 2 years actually, and they offer a lot. Authentication, authorization, feature flags, and soon they will also offer billing. So subscriptions will be super easy, as they say, ka-ching. So now you know what Kind is. And you know what? We will now implement Kind in a speed run. Let's do it in 1 minute or so. First step, let's sign in. As a next step, we want to create a new business. We want to add a business name, Kind domain, number of employees, and region. Let's save this. My business has now been created, so let me open my business. Now we have a little onboarding guide. So I want to use Kind with my existing code base. I want to use Kind with Next.js. Then I want to allow my users to sign in with email, Google, and let's select GitHub. Now we are almost finished. I want to now connect my Next.js codebase with Kind. So the first step is to install the SDK. Let me copy it, let me open my terminal, and let me install it inside of here. Kind has been now installed, which means I can restart my dev server. The next step is to now update our environment variables. So let me copy them and let's paste them in our env file. Inside of here, we now store our client ID, client secret, issue URL, and also, for example, our post login and logout redirect URL. Let's update our login redirect URL. So instead of redirecting the user to our dashboard, let's redirect the user to the index page. The next step is to create our API endpoint. So I can copy the route structure, I will go back, and then in my API folder, I can now create this new route. And also, instead of in route.js, we want to have in route.ts since we use a TypeScript project. And then I can copy this code and paste it inside of here. So this route handler is there to allow the user to log in, log out, authenticate, stuff like that. At the end of the day, this route handler talks to kind. And now there's only one more thing missing, and this is the kind auth provider, and this will give us access to the kind auth data in our application, and it will ensure that all of the tokens are refreshed when needed. So I can copy the code, paste it in my auth provider file. Then for my children, I want to pass the type, which is React Node, and then I want to wrap my whole layout inside of my auth provider. So I can copy the HTML, I can get my auth provider from my components, and I can again paste my HTML. So now we wrap everything in the auth provider, and now we are also finished with the kind setup in our application. The only thing which we want to now do is allow our users to authenticate. So let's open the navbar, and inside of here we have the login and sign up button. So again, if I go to the navbar, you should see inside of here the login and sign up button. But currently, if I click on the login button, nothing happens. So let's change that. What I can do is copy the import statement for the register and login link. I can paste it right here in my navbar, and then instead of rendering a button for login, I want to render my login link component. And instead of rendering the button for sign up, I want to have my register link. Now these two components are headless, so let's add a class name of button variants so that these two components look nice. And if you now again go back, you see we still have our login and sign up button. If I now click on sign up, we will get redirected to kind. Inside of here, I can now authenticate either with Google, GitHub, or with my email. I will select Google. So now I got redirected to my index page, but we have one problem. On the top right corner, I still render the login and sign up button. This means it shows the user that the user is not authenticated, but this is not true. The user has an invalid session. So above our return statement, we can do a constant, and I can destructure it, and this will be equal to get kind server session. Get kind server session is the server-side hook provided by kind. And then inside of here, I can destructure a function which is called getUser. GetUser is in promise, meaning we can do a constant user equals to await getUser. And now we have our user. Also, currently we get an error for await, so let's mark this function as async, and now we can use our user for our ternary, meaning if we have invalid session, we will render a logout button. If not, we will render the login and sign up button. So that's exactly what I've done right here. I have created a ternary. If we have a user, then we render a logout button, but if we don't have a user, then I render my login link and register link. And also for the logout, instead of rendering a button, we can render our logout link. So now this should be finished. This means if I save this and go back, you now see welcome Jan, and then we have a logout button. So now we make sure that the user has a valid session. This means if I go back to my route handler, we can now make sure that the user is authenticated and not some third-party user which tries to attack our website. So we want to do our check before we even get started with our request body and validating it. We want to do this authentication check at the top. So let's again do a constant. We want to destructure it, and this will be equal to get kind server session. I can invoke it, and as you all know, I want to get the getUser function. Again, this is a promise, so let's do a constant user equals to await getUser. So now we have our user, meaning we can do an if check, and we will say, hey, if there's no user, then let's return an error message. Let's again do a return next response.json, and then we can add a message and status. For the message, we will say unauthorized, and for the status 401. Let's save this. Let's go back. Let's first of all submit the form using our UI. So I will add a title, author name, and content. If I click on submit, we have a little delay, and then you should see a little toast on the bottom right corner. article created successfully. Let's now do the same with our terminal. So again, I have my curl command. We again do our post request. This is the same content, and let me click on enter. Aha, unauthorized. So we now make sure that the user is authenticated, and if the user is not authenticated, then we say, hey, you are not authorized to create this mutation. But currently I allow any authenticated user to create this mutation. But as mentioned, I want to only allow an admin user to create and block article. So let's again go back to kind. Let's go back to our home page. Inside of here, we want to go to our settings, and then in the settings, let's go to our roles. As mentioned, I want to create a new role. So for the name, this will be admin. For the description, this is an admin. And of course, you should describe the role in more detail, but in this example, this is fine. And for the key, this will be lowercase admin. We don't want to assign this to new members. And now let's save the new role. Let's now go to our permissions in the sidebar, and let's create a new permission. So for the name, this will be create new block article. For the description, this allows a user to create a new article. And for the key, this is what we will use in our code, or what we will reference in our code. So let's do create article. Let's now save this, and now we have our new permission. If I now go back to my roles and to my admin role, I can click on the admin role, and we want to add the permission, which is create article. So now an admin has the permission to create an article. Let me now go back to my users. So we have our users here. As you see, Jan Marshall. Let me click on the user. Let's go to the roles, and let's add an admin role. So I will select this, and then I can save it. So now I'm an admin. Let me go back to my application. I want to log out and again log in. And now we want to add this permission check in our code base. So here where we the structure get user from our getKind server session hook, we can also the structure get permission. And then underneath our constant user await get user, we can do a constant permission, and this will be equal to await get permission. I can invoke it, and as an argument, this is our key. And the key of our permission was create article. And now we want to also add this permission into our if check. So we want to now say, hey, if we don't have a user or if we don't have a valid permission, then let's return unauthorized. So we will use this double vertical line, which is the or sign. And this means if we don't have a valid user or we don't have a valid permission, then we will throw this error. Let me now log in with a different account, with an account which does not have the admin role. So I'm now logged in with a new account, and let's fill out the form. So some gibberish for the title, for the author name, and for the content. Let me click on submit. Article created successfully. Wait, I don't have the correct permission. Why did we just create an article? Let's again go back. Let's console log the permission, and let's again go back and let's click on submit. Then I want to open my terminal, and inside of here you see org code, okay, and is granted false. This means I don't have the correct permission. So permission is not just a boolean, but it's an object. So we don't want to check for just the permission, but for permission dot is granted. And if I save this and again submit my form, you should now see in a second an error. Unauthorized. So now we have covered server-side validation, authentication, and authorization. Now let's continue with our next mistake, or in other words, our next solution, and that's rate limiting. Now let's imagine that we wouldn't have this permission check, and we would allow every authenticated user to create a mutation right here. What is if a malicious user comes, creates an account, and then just spams our application the whole day, thousands of requests per minute? At some point in time, our database would be exhausted, our CPU would say, hey, leave me alone, and just our whole application would fail. How can we prevent something like that? Well, we can prevent it by using rate limits. Now here's the thing, Next.js isn't stateless, but most of you probably deploy Next.js to Vercel. Vercel is a serverless provider, meaning it's stateless. That means that implementing rate limits or rate limiting in general is not that easy. You have to use an external service. For this video, we will use ArcChat. This is not sponsored or anything. It's just my favorite solution. Nevertheless, you can, for example, also use Upstash rate limit. Upstash rate limit is an open source package which you can use with the Edge environment, but also with the Node.js environment. You only need a Redis database to make it work, because at the end of the day, you have to store the data somewhere. So we will use argjet, you can use upstash, it does not matter. At the end of the day, the result is the same. So first of all, we want to install the argjet SDK. So let me paste the installation command in my terminal. Then once installed, I can restart my dev server. Let's go back to the documentation and we want to go to rate limiting. Then inside of here, let's go to the quick start, and here we have a quick start example. First of all, we want to install the SDK. We already did that. The next step is to set our key. So let's copy the argjet key. Let's open our env file and I will paste it inside of here. Then I want to go into the argjet dashboard. In the argjet dashboard, I will create a new site. Then for the site name, I will just use the suggestion and then I can create my site. Now inside of here, I get my argjet key. I can just copy it and paste it in my env file. Then let's continue with the documentation. The next step is to now add rate limiting to our route. So let me first of all copy this constant aj equals to argjet. I can copy it, I can go to my route.ts and I can paste it above my export async function. So at the end of the day, this constant aj is just there to pretty much configure argjet. So we pass our secret key and we pass our rules. In this case, we want to use the token bucket. The token bucket is an algorithm. Argjet offers multiple algorithms, like for example the fixed window, the sliding window, or as mentioned, the token bucket. A token bucket means that at the end of the day, you have a maximum capacity, like for example 10. You have a refill rate of for example 5 tokens per interval, and your interval is for example 10 seconds. This means your token bucket has 10 tokens, and then every 10 seconds it can refill 5 tokens. Let's now import first of all argjet and the token bucket from argjet next, and then you also see we have a characteristics property, and this allows us to track the request using the user ID, since a user ID is unique and user IP can be, let's say, tampered with. So now this is finished, and now we can use argjet inside of our route handler, because currently this is only defined but not really used. So we can go underneath our authentication and authorization check, and inside of here we want to create a constant decision, and this will be equal to await aj.protect, and then we want to invoke it, and as an argument we want to pass our request. But now we get one error, and that's because we want to now pass how many tokens we want to take, and also we want to pass our user ID. So let's add a comma, open our object, let's pass first of all the user ID, and as mentioned, this is our kind user ID. So let's do the user.id, and let's also say for requested this will be 1. So this now means in this case we have our characteristic, this is the user ID, and whenever we do at the end of the day a request for this route handler, we take 1 token from our bucket. For the individual user, of course. This is not one general bucket, but a bucket per user. But now we are still not finished, because our decision now will tell us if at the end of the day the user is allowed to continue or not. Because if the user has already used up all of the rate limit, all of the tokens, then we don't want to allow the user to create a mutation. So let's do an if check, and we will say, hey, if the decision.is denied, let's invoke it, then let's open it, and I want to do in return next response. I can invoke it, and then we want to pass a message of too many requests and status of 429. Now to test everything out, I will change my token bucket a bit. We now have an interval of 60. This means we refill our bucket every 60 seconds with 2 tokens, and the maximum capacity is 2. This means in this case a user can only do or can only create 2 mutations every minute. And now let's test it out. So let's save it, let's go back, let me click on submit, and we are unauthorized. So let me sign in with the correct account. So I have now signed in with the correct account. Let me again submit the form, and let's see. This should be successful, and yes, it is successful. Let me again submit the form. This is also successful, and if I again submit it, we get an error. Too many requests. So I can also go into the argjet dashboard, and inside of here you see our request was denied, and the reason is rate limit. Alright, we have now set up server-side validation, authentication, authorization, rate limiting, and we are almost finished. Nevertheless, there are still a few things which we have to fix. So let's go back to our code base. Inside of here you see that I create my mutation, Prisma article create. I have my data, and then I return a next response.json. Inside of here, I provide my data, my message, and my status. Does it look insecure? Does it look wrong? Is there anything missing? Well, kinda. So let's look at the next response. As you see, I right here return my data. Now in this case, my data does not have any sensitive data because I only return the title, author and content. It's okay to return that to the client side. But now let's imagine right here this data would also store your credit card data. And now you didn't even check it and you just returned it to your client side. Because again, if you open your page.tsx, this is a client component. We marked it as use client, and this means if we return something, we will see it inside of here. So what does this mean? Well, this means you want to always double check what you return from your query because data is sensitive and you don't want to leak very sensitive data. So instead of just returning the data which you get from your Prisma query, I myself always like to create a separate object. So in this case, I would create a constant save data, and then this will be equal to an empty object. And then inside of here, I can pass all of the data, which I'm fine with leaking to the client side. So let's imagine in this case, my author is very sensitive. And in this case, I would currently just return this author name to my client side. But if we use our save data object, I can say what I want to return. So I can, for example, return my ID, which is equal to data.id. I can return my title, which is equal to data.title, and I can return my content. But I don't want to return my author. And then for the return next response, instead of returning the data, we can now return our save data. With this, we make sure that we don't leak data which we don't want to leak. Now, this is, in my opinion, my humble opinion, a best practice. I would never just return my data in the next response object right here because this is not safe. Let's imagine a new team member comes and just selects right here credit card data. Then you will automatically just return it right here in your next response and you wouldn't even double check it. With the save data, you can make sure and you can think through everything. And this is just like an extra safety barrier or security barrier. So that's something which I would always implement. So now there's only one more thing missing, and that's correct error handling. Because let's look at the code. We have authentication, authorization, server-side validation. We check for sensitive data, but we don't handle errors correctly. So I would always start with a try catch statement. So we can take all of the code inside of our export async function and we can wrap it or we can paste it into a try statement. Then let's also get a catch statement, let's get an error and let's open it. Now this try catch statement is very beneficial because it's very graceful error handling. What I mean with that is your application won't crash. If there's some sort of error inside of here, we will catch it in the error and then we can return a general or a very specific error message. So most people would go inside of here and just say, hey, let's just return a next response and let's say internal server error. I mean, I guess this is fine, but in my opinion, your error messages should be as specific as they can be. This is a very general error. It does not tell us anything about the error itself. So here's what I would do instead. I would first of all double check if the error is maybe in Prisma error, because as you see right here, we don't handle any Prisma errors. So in the catch statement, we can do an if statement and we can say, hey, if the error is an instance of uppercase Prisma, so let's import that from Prisma client, dot Prisma client known request error. If this is true, then we can open it and let's do return next response.json. We can invoke it and for the message, we will say database error and then for the status 500. So with this, we now handle errors more precisely. We don't just throw in general internal 500 error, but we check, hey, is it in database error? If so, then let's return in database error. If not, we can return in general error. So let's again do next response, return next response.json, and then for the message, we will say internal server error and for the status 500. So again, if it's in database error, we will return in database error. If not, we will just return an internal server error 500. Alright, so we are now kinda finished. Let's again summarize everything that we did inside of this route handler. We started with server-side validation. We check our form data, our JSON, against our sort schema. Our sort schema is like a file with multiple rules. And we check that our data, which we get from our unsafe client side, we check that it compares correctly to these rules. If so, we continue with the mutation. If not, we throw in validation error. As in second step, we implemented authentication and authorization. We make sure that the user is authenticated and we make sure that the user has the correct permission. As a next step, we also implemented rate limiting, because let's be honest, malicious users don't care about you. They want to exhaust your database and your application. And using rate limiting, we can prevent that. We can say, hey, this user can only do XYZ amount of requests. After that, we implemented our sensitive data validation check, if this makes sense. So instead of just returning our data in our next response, we create a separate object and then pass our data inside of there. Because with that, we can just make sure that we know what we return to the client side. And as a last step, we wrapped everything in a try-catch statement to, at the end of the day, handle any errors. We make sure that if it's in database error, that we also throw in database error, but if it's in general error, then we just throw in internal server error. So now we have a super secure and a super scalable route handler, which works as we would expect, which is great. Now the code which we have written inside of here is also applicable to your server actions. You can take the code and also implement it inside of there, because as you all know, a server action is a public endpoint, just like a route handler. And now, I hope you enjoyed this video. Please don't forget to like and subscribe. It would mean a lot to me, to my heart, to my head, if this makes sense. I don't know. Please just hit the like and subscribe button. And yeah, I hope you enjoy your day. I hope I can see you in the next video. So yeah, bye. By the way, what do you think of the t-shirt? Looks cool, right? Man, I pretty much said in every outro, right, that this t-shirt looks cool, but it is cool. Right? Oh, by the way, do you want to see the background? Wait. Ba-ba-ba-ba-ba-ba-ba. Yeah. Looks fine. Bye.